Good day to each and everyone. I am Jason De La Hencia, and I am here together with my team to discuss to you our research entitled Diabuddy, a dietary plan mobile application for type 2 diabetic patients using clustering algorithm. Mobile applications are increasingly being utilized to help people improve their nutrition. Some apps can provide nutrition plan and some apps can provide tips and ideas on how to improve the physical lifestyle and nutrition of the users. Philippines is a rice-dependent country when it comes to food. That's why Filipinos are prone to diabetes. There are two types of diabetes. Type 1 diabetes, which is insulin dependent, and type 2 diabetes, which is manageable by improving the nutrition of the patient. Since type 2 diabetes is manageable than type 1 diabetes, the team wants to create a mobile application that can help people improve their nutrition by giving the right meal plan for the patients. But the question is, what is the best clustering algorithm in terms of food recommendation to use in the dietary plan mobile application for type 2 diabetes? Next slide, please. The researchers used the IPO model or the input process output model. The input stage consists of knowledge requirements such as knowledge about type 2 diabetes. The dietitian and endocrinologist knowledge will also help to provide more information about the diabetes. Sample mobile application in food recommendation, and lastly, Filipino food dataset that can be used in creating the mobile application. The process stage shows the process of gathering and analyzing of data. This includes the data gathering procedure, the survey questionnaire for diabetic patients, interview with the dietitians, processing and analyzing data, designing the key feature which is the food recommender system, comparison of algorithms, the K-means clustering algorithm and fuzzy Z-means clustering algorithm through the silhouette validity technique and silhouette index. The output stage will show the best algorithm in terms of food recommendation that will be applied in the entire plan mobile application for type 2 diabetic patients.
Hi, my name is Marian. For our research design, we employs with both developmental and descriptive research to prove which is the best algorithm in terms of food recommendation. We use a developmental research to improve current study and develop solutions to existing problems, and must meet the criteria of consistency and effectiveness. We also use the descriptive research that is relevant to our study in order to improve and gain better understanding of the subject, algorithms, and techniques. We also use an 8 stages iterative cycle diagram to enumerate our research process from the data collection through data analysis. This will encourage us to complete the objectives of the study and facilitates to get best solution for the research problem. Thank you. Next slide, please.
Hi, I'm Stephanie. Good day. In this study, we decided to use the mixed method, which is the qualitative and quantitative research method, in order to reach the goal of getting the best result from the data gathered. Quantitative survey questions are best for gathering basic profiles of the diabetic patients, such as their age, sex, and what type of diabetes they have. On the other hand, we have qualitative questions. It aims to gather data that is not easily quantified, such as how the dietitian manages the patients with type 1 or type 2 diabetes, and how do they recommend diet plan to their patients. In conducting a survey, we used a survey questionnaire about diabetic person's condition, dietary meal plan, and self-care. In this study, we also conducted an interview with a nutritionist dietitian who have been in practice for 26 years and working on Philippine General Hospital. From this interview, we gathered the data about the management of type 1 and type 2 diabetes and the approach of recommending diet plan to the diabetic persons. For the algorithm, there are two clustering algorithms that we used and tested in order to determine the best algorithm that suits our system in terms of food recommendation. First, we have the K-means clustering algorithm. It is a machine learning technique that involves the grouping of data points. K-means is the most well-known clustering algorithm. It is necessary for our application to have an accurate categorized meal in order to generate an accurate food recommender system. So here's how the K-means clustering works. As you can see in the flow chart, initially we could pick k random points and make those as starting points. For every data point, the algorithm looks at which centroid is nearest to it. Then it assigns the data point to the nearest centroid. And then for every centroid, the centroid moves to the average of the points assigned to that centroid. We can stop the algorithm if the centroids of newly formed clusters are not changing. Even after multiple iterations, if you are getting the same centroids for all the clusters, we can say that the algorithm is not learning any new pattern and it is assigned to stop the training. For the second algorithm, we used fuzzy C-means clustering to compare it to K-means clustering. Fuzzy C-means clustering is a soft clustering approach where each data point is assigned a likelihood or probability to belong to that cluster. This algorithm works by assigning membership to each data point corresponding to each cluster center on the basis of distance between the cluster center and the data point.
Good day, everyone. I am Miko, and I'm going to discuss the results and analysis of the study. These figures show the result of k-means clustering on the food dataset in a scatter plot with a total of 306 data points. The figure on the left, with only blue data points, indicates unclustered data, while on the right side, with colored data points, indicates the clustered data. By performing the k-means clustering, the data points are classified by similar amounts of calories and carbohydrates, since these two nutrients are the main factors to consider in recommending a food to a diabetic patient. So what happened here is that k-means group the data into specified number of clusters by minimizing the distance from each data point in a category to the center point or centroid in each group. As we can observe here with the result, yellow data points are the dominant color because K-means only cares about the point to centroid distance when categorizing, not the number of data points in a category. Next, we have here the result of fuzzy C-means clustering performed also with our dataset. Same with the previous slide, we have clustered and unclustered figure. And since we specify the number of 4 clusters in k-means, we also use 4 clusters with the fuzzy C to have a balanced comparison. As we can clearly observe with our result that there are overlapping colors in the plot. In fuzzy C, each point has a weighting or a weighing associated with a particular cluster, so a point doesn't sit in a cluster as much as has a weak or strong association to the cluster. Next, we have here the algorithm testing and evaluation. Unlike supervised learning algorithms, which can be evaluated by measuring error or accuracy and recall, clustering algorithms cannot be so easily assessed in this manner. For example, the distance between points in the cluster is taken into account while scoring clusters. If the clustering method differentiates similar and dissimilar observation, it performs well. As a common assessment metric for clustering methods, the silhouette coefficient was utilized in our study. If the coefficient is close to 1, it means the sample is well clustered and already assigned to a very appropriate cluster. If it's about to 0, the sample would be assigned to another cluster closest to it, and the sample lies equally far away from both the clusters. That means it indicates overlapping clusters. And close to 1 means sample is misclassified and is merely placed somewhere in between the clusters. And here we can see the result of the silhouette validation technique for each cluster. K means clustering as a score or coefficient of 0.616, and fuzzy C-means with 0.565. The result of fuzzy C-means clustering is less than the silhouette coefficient of K-means clustering, which is closer to 1. Therefore, the K-means clustering algorithm performs better than fuzzy C-means in clustering in terms of food recommendation. We now have the conclusion based on the findings of the evaluation in this study. According to the standard range of silhouette value, the data points in K-means clustering are assigned to a very appropriate cluster based on the standard range of silhouette value. As illustrated earlier in the result, the fuzzy C-means clustering algorithm produces clusters that overlap with one another. When using fuzzy clustering, rather of being completely confined within a single cluster, as is the case with K-means, different data points were included in other clusters in addition to their own. In conclusion, when it comes to food recommendation clustering, the K-means clustering algorithm outperforms the fuzzy C-means clustering algorithm. Choosing the appropriate nutrition for diabetic patients is critical. Therefore, clustering the food based on its nutritional worth is also necessary, and by employing a non-overlapping algorithm, the food recipe are grouped together in a single cluster. Any meal recipe that belongs to more than one cluster is prohibited due to the fact that each has a varied nutritional value. It is anticipated that the K-means algorithm will be implemented in the food recommender system for diabetic patients in order to generate a dietary plan which will be of significant assistance in the prevention and management of the disease. We are now going to system demonstration.
For the system demonstration, we use an Android 10 mobile phone. For the login, you cannot log in once the system checks that you don't have an account. You need to sign up if you don't have an account. This part is the sign up for email and entering your password. Once you're done with that, the app will request to fill up fields for your age, gender, and physical lifestyle. These will be the factors needed when the system is recommending your meal plan. It will only succeed once you enter the correct email and password for your account. The main page of the application shows the food recommendation based on the age, gender, and physical lifestyle you entered upon creating your account. These recommendations are made and approved by the dietitians and the nutritionists.
Next is the dietary plan customization feature. This allows the user to change the meal if he or she doesn't want the food. The user can also change or replace the meal if he or she had a food allergy.
For the user's profile, this is where all the important information of the user will get stored, including the age, gender, physical activity, and the daily calorie goal. Next is the food diary. It will allow user to see their food taken history, which will help them monitor what they consume and when they consume the food. Next is the nutrition tracker, in which the user can utilize this feature to keep track of their nutritional intake, especially for the calorie goal. Lastly, we have the recipes. The user can view all the recipes and their nutrition facts. They can also search for a specific recipe. Next is the demonstration of the admin side.
For the admin page of the system, we have here the manage recipe feature where we can see or we can browse the different recipe from our dataset, and we can also edit some recipe, and we can also delete some recipe there. And next, we have here one of the main feature of our admin side, which is the add recipe feature. Here In other recipe feature, we have the clustering algorithm integrated. So now let's create a new sample recipe with the same carbohydrates and calories to one of our existing recipe, since those two nutrients are the main factor used in our clustering algorithm, and to check if the new recipe will fall into the same cluster as the existing recipe. For example, let's copy the calories and carbohydrates of adobong sitaw, 601 and 1.5. So let's add, let's say, a sample recipe with 601 calories and 1.5 carbohydrates. And for the other inputs, let's just put random values into it. Then after adding new recipe, a message will pop up saying that the recipe has been added. And now let's check our new recipe. So sample recipe. So as we can see, our sample recipe falls into the cluster 2 in our data set or in our database. So let's check the adobong sitaw. As we can see, adobong sitaw also falls into the cluster 2. So this means that our clustering algorithm works, and that's it for our admin page. Thank you.